that kind of summarizes where I am on the IPv6 and IPv4 side. If you have an exploit, if you know what particular country or you want to hit the entire internet, it's pretty damn cheap to do it, and it's pretty quick to do it. You don't really need specialized hardware. You don't need more than a couple $100 in a debit account to go to town with this stuff. So let's talk about RAM a little bit. And RAM is fun because, it's cheap. It's finally really, really cheap. It's 23 gigs for a gigabyte right now off of a price watch. The funny thing about RAM, though, is even though it's it's 2 cents per megabyte, and netbooks are shipping with 1 gig or 2 gig by default, like this little crappy thing has like 2 gigs of RAM in it. It's insane. Even your video cards these days have more RAM than servers we had 10 years ago. It's nuts. But the funny thing about RAM is the prices aren't derived based on capacity or speed or anything like that at all. They have no relation whatsoever to the performance or the specifications of the RAM at all. They're built entirely based on the supply. So the supply chain determines the price. That's it. So if you look at RAM for DDR2, original DDR RAM at 400 megahertz is actually way more expensive than the RAM that's available today for your modern systems. So unless you're buying exactly the right peak point, you're going to get shafted on RAM prices. So this chart, which is really tough to read from the back, I apologize, shows that there's actually a 6-year peak for every type of RAM that's being developed between when the supply peaks and when the next technology becomes available and the previous peak becomes more expensive. So it's a kind of an eye chart to read, but the very far right line there, this graph is a little bit old, is actually 1 gig sticks. And you can see they actually peaked around I think their estimated peak right around 2009, 2010, which is right about where we are. We're at $23 for a gig of RAM. So even though this actual chart is from 2006, 2004, I forgot when, they actually managed to predict the peak for 1 gig RAM price points early on just by watching how supply and demand had changed this graph. And for the most part, demand is always there. Everyone always wants more RAM. You're never going to say, no, I would only like 512 megs of RAM. My wife does, but that's entirely a different story, and I can't sell her on the magic quantity, the magic properties of having too much RAM. Anyways, long story. So depending on how old the RAM is and how outside of these supply peaks they are, the more expensive the RAM becomes. But the short answer is, you're paying 2 cents per megabyte right now for most systems. So most systems have tons and tons of RAM. You're not going to buy a system with less RAM than a $20 upgrade is going to cost to upgrade it. I mean, it doesn't make sense. I mean, Apple may charge you $80 for a RAM upgrade, but you can go to the store and spend $20 on it. You're going to do it. So what's important about RAM is that 2 gigs of RAM is enough memory to store 127 different states for the entire internet. With 1.8 billion internet users, you can actually store more than that. You can store almost, I forgot what it comes out to, almost 67,000, 68,000 states for every active internet user, just in 2 gigs of RAM. I mean, granted, you're not talking about storing their history and their logs and things like that, but if you want a big pie chart of the commies versus non-commies, that's easy. That's only 1 bit. So you look at how easy it is to track systems and track people and track devices these days, and the amount of memory available just to some crappy little netbook is way more than enough you need to track the entire IP, the entire internet range, the entire internet user base for small tasks that are kind of, purpose specific. So if you look at how RAM really drives the market, RAM is actually driving software requirements. The cheaper RAM is, the more RAM available, the more your OS will require. We looked at making Metasploit faster and use less memory. Then we're like, wait, let's just wait 6 months, see if people still complain. And it seemed to work okay. It's like, now RAM's cheaper and no one cares. I mean, one of the reasons why Java got a lot of crap back in the day is it was somewhat inefficient at memory handling, and it needed kind of a pre-allocated block of memory. No one liked that. These days, people have so much free memory, they're like, yeah, sure, Java, you can have 4 gigs. I don't care. I've got 10 more, at least for servers. So if you look at Windows 2000, it had a 32 megabyte RAM requirement. That was the minimum for it. What recommended was like 64. Recommended usually double. Windows 7 has 1 gig requirement. Office 2000 has an 8 megabyte requirement on top of your OS. Office 2010 has 256 requirement on top of that. Now the funny thing about these is they're exactly a 32x multiple for both products. You can go look at almost every Microsoft product over the last 10 years, and they've increased exactly by 32 times what the RAM requirements are for them going forward. And Linux has done, not quite 32x. They've gone about 2 or 3x, but it's funny to see how even disparate products that have different development teams came up with the same RAM requirements when it was all said and done. So I guess you just make up a big number and hope people will buy that much RAM. And hopefully the RAM developers or the RAM manufacturers are giving some kind of kickback to Microsoft for pushing this. So one of the cool things about, one of the best resources I found for what people are actually running and what hardware people actually use are the gamers, because there's a lot of surveys out there that gamers will respond to saying, I'm running, a quad core, blah, 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 or I've got this much RAM, and they love to talk about system specs and share the information. Well, they love to share it so much that the Steam software by Valve doesn't even ask them for permission. It just takes their system info and puts it online in a survey every month. So if you want to see how many people are running 64-bit processors, how much RAM is actually current in the wild, basically how well will this exploit work? Should I bother porting this exploit to this platform or adding a 64-bit target? You can just look at this hardware survey and get a really good idea of whether it's worth your time to do it. This is kind of an eye chart, hard to see, but it's basically if you search for hardware survey at Steam, you'll find it right away. So the cool thing about this is the gamers usually set the trend for 2 or 3 years in the future. So 2 years after the gamers jump on technology, it starts to trickle out in the enterprise. Things like quad-core CPUs, over 4 gigs of RAM for desktop systems, those have all kind of created the trends that eventually trickled down to enterprise and businesses and your average user 2 to 3 years later on. 84% of all gamers that use Steam have over 2 gigs of RAM or 2 gigs of RAM. So 2 gigs is half of your 32-bit space. It cuts it right in half, and that becomes important when you look at the exploitability stuff later on. 27% actually have more than 4 gigs of RAM, which means unless they're even running a 64-bit OS, they're not even able to use most of that under Windows. And these are all Windows users. There's no, I guess there might be 2 Mac users in this big spread somewhere, but probably not. Only 4% of the people who use any game provided by Steam have less than 1 gig of RAM. So when you look at targeting exploits, look at how feasible a particular exploit is, things like heap fill, memory fill, take this stuff into account, because you can say, well, only if you have tons and tons of memory will this exploit work. Well, guess what? People do have tons of memory. At least all the gamers, and they'll eventually become real people that you can exploit later on. So if you look at how 32-bit processors really kind of constrict system memory, most 32-bit CPUs can only address 32 bits of memory. That's just how it works. Virtual memory space, not directly RAM. Virtual memory space includes your device drivers, includes your I/O, includes all sorts of things. You can use PAE, which is physical address extension, some other tricks to be able to address more than 4 gigs of memory, but it's a little bit slower, and the more RAM you have to address, the more memory you have to create a separate PTE table to look up the RAM in the first place. So this chart here is actually from Mark Rosanovich. He had a system with some insane number of cores with 96 gigs of RAM, but running a 32-bit version of Windows, and he can only actually use 2 gigs of it. So it's a great picture. It just gives you an idea of how inefficient this can be. So you've got all these awesome CPUs, and it's you've got 92 gigs of RAM, but we're just going to sit on 90 gigs of it for now. If you look off to the right, the chart on the right gives you an idea of how memory is actually broken down. From 0, basically from the top down, that's your normal user memory per process. The red chunk there is your device memory. That's your I/O mappings to your video card, things like that. If you've ever gone to your BIOS and you found some weird BIOS lines saying, what is your AGP aperture, or what is your memory card aperture, that's how much I/O memory is getting mapped to your memory space. So if you've got a 32-bit OS and you've got 4 gigs of RAM and you tell it to allocate 512 megabytes as your AGP aperture, you're losing that much actual memory you can use, because it's using all that I/O space to map directly to the video card. So depending on how much crap you've installed on your computer, if you're running a 32-bit OS, your maximum is only about 2 gigs to 3.5 gigs, depending on how much other crap you have and things like video card mappings, stuff like that. So if you look at 32-bit versus 64-bit penetration, we've got, we're going to go ahead and look at the Steam hardware survey again, because it's a great data source. I haven't found it anywhere else. 33% run 64-bit Windows overall of the gamer crowd, which isn't too bad. I mean, it's a sizable chunk. It's more than I expected. 28% run Vista or Windows 7 in 32-bit mode. Wait, so only 28% of new OS users are running 32-bit mode? Yes, so 54% of Vista and 7 are actually 64-bit. There's some gaps in the survey results. This was the way I summarized it. You can see the full trend online. So anyways, great stats. If you're trying to figure out whether 64-bit's worth exploiting, or how far a particular exploit's going to go, this is a great way to look at it. And the funny thing is, you can see that 54% of all Steam players are running one of the most recent Windows OSs. No one's really running XP on that side anymore. XP is mostly businesses or third world or grandma or us holdouts. So yeah. So the next graph down here is actually the CPU the number of CPUs shipped over time that supported 64-bit versus just 32-bit mode. Now, if you look going back to 2003, there weren't any desktop CPUs being shipped to 64-bit mode. If you go into 2004, they're almost at 20% already. You go all the way to 2007, you're actually 60% of all the CPUs being shipped has 64-bit compatibility, can actually go into 64-bit mode, either EMT 64 or AMD 64, whatever the new terminology is now. At the 2008 Microsoft WinHack conference, where they do all the hardware engineering, you can look at the percentage